Alright, today we're doing section 5-7. It's all about graphing and solving quadratic inequalities. So our goal is to graph quadratic inequalities and to solve quadratic inequalities. I think I just lied to you. I think the last 2 examples are on notebook paper, but most of them are on graph paper. Tomorrow we are finishing up the chapter. Your homework check is this Friday, review Monday, test Tuesday. Then that will give us a full week before Thanksgiving to get some new material in. Alright, so here is number 1, graphing a quadratic inequality. So we want to graph y is less than or equal to x squared plus 2. To find your vertex, this is where we do the negative b over 2a. What's b in this case? There isn't a b, so what do we put? 0. A is 1. So the x value of our vertex is 0. How do you find the y value? Plug it back in. Good. When I plug it in, remember, put it in parentheses. Whatever you're plugging in, it'll help you keep your signs straight. Also notice that instead of thinking of it as an inequality, we want the actual value, so just change it to an equal sign when you're finding it. When it's an inequality, you have a whole range of answers, but we just want the 1 point, so just change it to an equal sign. When you plug in 0, you end up with y equals 2. So my vertex is at 0, 2. Now, do you guys remember how to graph the rest of this? You could think about what we learned with transformations, right? So this should open up because it's positive. The a value is positive, remember, so it won't flip downwards. It shouldn't get wider or skinnier because a is just 1. So it should look pretty much like a normal parabola. You don't really have to write that. That's just kind of getting you to think back to the graph transformations we thought about. What were you saying? Yeah, we can do an XY table. What should I plug in? 1. Good. When you plug 1 in, what do you get? 3. So that gives us those 2 points. I would do 2 more because that's kind of not much information. So let's plug 2 in as well. 2 and negative 2 will give us the exact same thing. What does it give us? 6. So now I have points at negative 2, 6 and positive 2, 6. I'll give everyone a second to catch up. Now, since we're graphing an inequality, think back to when we did linear inequalities. You have to decide if it's a solid line or a dashed line. What do you think here? Solid, good. So we can go ahead and graph our parabola. Then you have to decide if you're going to shade inside the parabola or outside the parabola. The easiest way parabolas is to just do a test point. So I'm going to test 0, 0. If I plug 0, 0 into our original inequality, I would get 0 is less than or equal to 2. Is that true? Yeah. Yes. So I would shade the region that includes the 0, 0, which is that region outside of the parabola. Now, the hardest part of today's lesson, I think, is recalling how to graph parabolas. Remember, we kind of struggled with that on the last quiz, so make sure you're reviewing what you know about parabolas. The negative b over 2a part is crucial, and then just plug in points on either side to get the rest of the shape. Then must decide solid or dotted, and then shading inside or outside. Questions? First thing I'm going to do is find our vertex. So I do the negative b over 2a. What's b in this case? What's a? Negative 1. Good. So you're going to have a negative on the bottom and a negative out front. A negative, negative, of course, becomes a positive. So my answer here is positive 1. How do I find the y value of the vertex? Plug it in and good. We want to think of it as an equal sign. You think of it as an equal sign too when you're finding the other points. The inequality symbol just comes in when you're deciding whether to shade and what type of line to use. So when I plug in I'm plugging a positive 1, but it'll be a negative 1 up front. After you square it, make it negative, so we'd have negative 1 plus 2. Hold on. That's not right. Yep, it should be positive 1. Oh, there it is. Sorry. I did not do enough animation. Yep, it's negative 1 plus 2, which is positive 1. Sorry, my bad. That day off's got me all confused. So my vertex is at 1, 1. Now, let's just kind of reason through what this graph should look like. Should it be opening up or down? Down. And then is it going to get like any skinnier or fatter or anything? No. Just because A is negative 1 just means that it's going to flip across the x-axis. It'll be facing down. But it's going to have a normal shape. Remember, if there's a number in front like 2 or 3 or 4, that's when it gets real skinny. Or if there's a fraction, that's when it gets real fat. But this one should just have a normal shape to it. Now, what are some other points we can find out? You can put 0 in. When you put 0 in, what do you get out? 0. So that'll give you the point 0, 0. It'll also give you the point 2, 0 because it's symmetric. So we have these 2 points. You can put, we just put 2 in, we got 0. So we could either put negative 1 in or 3 in. They should give us the exact same thing. When you put negative 1 in, you get 1 squared, make it negative, plus negative 2 because you multiply it by negative 1. So negative 3. And then you also have it 3, negative 3. Any question on how I'm getting those points? All we're doing is plugging numbers in, so I'm not showing too much of it. Just talking it out loud. Now, is this going to be a solid line or a dashed line? Dashed, good. Oh, there's 2 more points. I wouldn't worry about those 2. So it should look something like this. I always think 5 points is plenty. Now, we have to decide where to shade. Can I use the test point 0, 0? No. No, because it's on the line. That's not going to help us with anything. So I'm going to test the point 1, 0. That'll put me right inside the parabola. So if it's true, I'm going to shade inside. If it's not true, I'm going to shade outside. So when you plug it in, you have 0, and then on the right side you'd get negative 1 plus 2, which is 1. So is 0 greater than 1? No, so I need to shade outside of the parabola. What are your questions on this? So example 3 is y is greater than or equal to 2x squared. How do I find the vertex? Very good. Negative b over 2a. B in this case is 0. A is 2. So you'd have 0 over negative 4, which is just 0. When I plug 0 in, it's pretty obvious that I am going to get a 0 out. So my vertex is at 0, 0. Now, just sort of thinking of how this is going to look. Any ideas? Yeah, it's going to be a little skinnier, right? It's going to go up 2 times faster. You don't really have to make this note. This is just reminding you of our transformations, of course. So it's going to shoot up 2 times faster. So it's going to look a lot skinnier than our last 2. All right, the next thing we can do is plug some points in. So when I plug 1, either positive or negative, what do I get? 2, good. You do 1 squared, then times 2, so you get 2. Again, that's the 0.41 and negative 1. When you plug 2 or negative 2 in, what do you get? Well, 2 squared is 4. 4 times 2 is 8, so we're all the way up there. See how quickly? And then it's an or equal to inequality. So it's going to be solid, so it looks something like this. I will pause here, let you guys catch up. Now we want to test a point, so let's check 0, 1. When I plug 0, 1 in, I would get 1 is greater than or equal to 0. 0, 1 is inside the parabola right here, so am I going to shade that region? Yes. Questions? All right, now we're going to look at how to graph a system of inequalities. So basically that means you're going to do the same thing twice and look for the overlap. So on the first one, I need to find the vertex. Anyone know just looking at the first one where the vertex will be? 0, 0. Yeah, we don't have a b value, so it'd be 0. When you plug 0 back in, you get 0. Pretty simple. What happens when I plug 1 or negative 1 in on the first equation? What happens when you plug 1 in? You get a negative 1. What happens when you plug 2 in? Negative 4. Good. And again, that happens positive 2 or negative 2 because it's symmetric. What type of line will this be? Solid. Good. So it looks like this. Now we can test a point. I'm going to test 0, negative 1. So again, that'll put us right inside the parabola. So if it's true, we'll shade in here. If it's false, we'll shade all of this out here. And again, I'm just working with the first one right now. We haven't gotten to the second one yet. So when I plug 0, negative 1 in, I'd get 0 over here. I'd get negative 1 on the left. Negative 1 is less than or equal to 0. That's true. So I'm going to shade inside. I'll pause here, let you guys catch up. All we did was graph that first parabola. And again, if we're looking at it, this is a pretty easy parabola because remember, it's just the parent parabola, the regular old parabola we're used to, just flipped across the x-axis, so it looks good. This one is actually the regular parent graph parabola, just shifted down 4 units, so we already know it should end up like right here, but we'll go through the process just to be sure. The vertex of this one, there's no b term, so again, it's going to be 0. As our x value, when you plug 0 in, 0 minus 4, you get negative 4. So my vertex for my second parabola is actually right inside the first parabola at 0, negative 4. When you plug 1 or negative 1 in, you'd get 1 minus 4. That's negative 3. So I now have points at 1, negative 3, and negative 1, negative 3. And then the intercepts are actually at 2 and negative 2. So now I have those points. Now this one's also going to be solid because it is an or equal to. So right now you should have those two parabolas. We still need to decide where to shade. Remember, if we would shade outside of our second parabola, the overlap would be down here. If we shade inside, the overlap will be this shape right in the middle. So I am going to test the point 0, 0. When I test 0, 0 in the second inequality, I get 0 is greater than or equal to negative 4. So that means that inside of the parabola is where we're going to shade. But remember, for inequalities, we're only really interested in the dark region. So where the overlap is, shaded in extra dark. You could actually erase the blue and the yellow part if you'd like, or just make sure that the red part, the overlap, is very obvious.
What did you put in to get those last 2 points for the last one you did?
I put 2 and negative 2 in. And I knew that 2 made the equation 0 and negative 2 also made it 0. So that's how I got the point 2, 0 and negative 2, 0. What are your questions on a system of inequalities? It's basically just 2 problems in one, and then you shade the overlap. All right, let's do another system. The first line, or sorry, the first parabola should be a breeze for us. We've graphed that 1,000 times by now, probably. The vertex is at 0, 0. When you plug in 1, you get 1. When you plug in 2, you get 4. It's going to be solid. Looks like this. Like I was saying, that's the one we graphed over and over and over and over during our transformation activities, so you guys should be pretty good at that one. However, we do have to decide where to shade, since this is inequality now. So I'm going to test 0, 1, that'll be right inside the parabola. If it's true, I shade inside. If it's false, I shade outside. So I would get 1 is greater than or equal to 0. That's true. So shade inside. I will pause there and let you catch up. What are your questions? All right, let's look at that second one. So the second one's written sort of out of order. What's the B value on the second one? Nope. It's written out of order. Yeah, the B value is 4, so don't be tricked by that. So we would have 4 over 2 times, well, you'd have negative 4 because it's negative B over 2A. A here is negative 1, so you'd have negative 4 over negative 2, which is just 2. Remember, I just did negative B over 2A. 4 is the B, negative 1 is the A. When you plug that back in, you'd get 8 minus 4, which is 4. Just looking at this, since A is a negative number, I know it's going to be going down. So once you get the vertex graphed, which the vertex actually falls on our first parabola, I know it's going to open down. We could plug 1 in. When you plug 1 in, you get 4 minus 1, which is 3. That also gives us the point 33. When you plug 0 in, you'd get 0, which also gives us the point 40. It isn't or equal to, so it's going to be solid. You can add those points down at the bottom if you want, but like I said, I think 5 points is more than enough to graph a parabola.
What was the last point?
The last point that we were talking about, when you plug 0 in, you get 0. So 0, and that also gives us 40. The graph on the board has these extra points. I would not worry about these extra points, but you get it by plugging negative 1 in. But again, I think that's a little extra work. You can already see the shape just by doing the first 5 points, so I wouldn't worry about these. Now we need to test a point to decide where we're going to shade. I'm going to test 1, 0. That is going to put me right inside our second parabola. When you test 1, 0, you get 0 is less than or equal to 3. 0 is less than or equal to 3, so we would shade inside that parabola, and then the overlap is just that little chunk there. This is a different type of problem. This is just solving a quadratic inequality by graphing. It's a different type of graphing than you'll think of. So we want to factor this, right? When I factor this, my multiply number is negative 6. My add number is 1. So it'd be 3 and negative 2. So I'd have x minus 2, x plus 3. I'd divide them both by 2, right? So it'd be x minus 1, 2x plus 3. Any questions on how that factors? All right, the animation will just fill it in for us. They do it a little different. So there we go. So when I'm finding the x-intercepts, you solve each of those, right? So 2x plus 3 equals 0. That would give us negative 3/2. What would give us 0 in the back? 0 in the back. 1, good. You guys are sleeping on me. All right, so to graph this with the x-intercepts, I would have one of them at negative 3/2, which is like negative 1.5, and then I have one at 1. Now, I'll show you guys the main goal here, because actually precision isn't too terribly important here. We are looking for where we're going to be greater than or equal to this parabola we're about to graph. So it doesn't really matter if your vertex is exactly correct. It doesn't matter if you have all 5 points lined up perfectly. It just sort of matters where is it going to be greater than this line. Okay? So, just real quick, will this be opening up or down? Up. How do you know it's going to be opening up? Because A is positive, right? All I care about is whether it's going to be above or below the x-axis at this point. So you can very quickly just sketch it in. We don't even need to know the precise value of the vertex. It is opening up, so just sort of whoop, draw it in. Again, if you want to be very precise and do negative b over 2a, or remember you could find the average of the x-intercepts and do it that way. But just by looking at the a value, we can just very quickly sketch the parabola. Any questions on that? Now, where is the graph below 0? Zero is our x-axis. Where is our graph below the x-axis? Because I want to know where is this parabola less than 0. That's what this question is asking me. So does anyone know where it is less than 0? Less than 0 means below the x-axis, right? The x-axis is where it changes from positive to negative. So it's below the x-axis when you are between the x-intercepts. So between the negative 2/3 and the positive 1 is where this parabola is less than or equal to 0, or 0 is greater than or equal to this parabola. So again, these are quick sketches. I'll show you an alternative method using a number line that students sometimes prefer. But basically, remember, we're just trying to do a quick sketch of the parabola using the intercepts. The intercepts are the important part. And then you just decide if it's above or below the x-axis, and then which part are you looking for? Here we're looking for where it's less than the 0. So we're looking for below the x-axis. What are your questions on this? Let's check out another one. So remember, the important part here is our intercepts. So we want to find our intercepts first. We don't like to graph, or at least I don't like to graph, when the a value is negative. I like to make the a value positive. So we can actually just move everything to the other side of the equation. So I added x squared, I subtract 2x, and I subtracted the 8 as well. So everything's on the other side of the equation, and now we're left with 0 on the right side. Any questions on that first step? Now I want to factor this. How is this going to factor? It multiplies to negative 8, adds to negative 2. Anybody? Negative 4 and 2. Good. You guys know this a little better than you're showing, I believe. So what are my intercepts? Positive 4 and negative 2. Good. The intercepts are what makes this each binomial equal to 0. So looking at my graph, I have a point at -2 and I have a point over here at 4. Yes, now if we were going to find the exact precise value of the vertex, I would find right in the middle, it'd be 1, and then I'd plug 1 in. Do I need to be too precise here? I'm only concerned with how it relates to the x-axis. Can I tell just by looking at the equation where it's going to be with the x-axis? We're looking at this one. Is it opening up or down? Up, right? Here the A is positive, so the intercepts that we found, the A is positive. So it is opening up. That's really all you need to know. If you want to be extra precise, plug 1 in. 1 is the x value of the vertex. I know that because it's halfway between the 4 and the -2. When you plug 1 in, you get -1 plus 2 plus 8. Oh, I'm looking at the wrong one. You'd get, sorry, 1 minus 2 minus 8. I was looking at this equation, not this one. That puts us all the way down here at -9. And then we can go ahead and reason through our inequality. Now, looking at this inequality, I want to know where my parabola is less than or equal to 0. Remember, 0 is our x-axis. So is it between our intercepts that it's less than 0 or outside of our intercepts that it's less than 0? Is it below the x-axis between the intercepts or outside of the intercepts? Where is the line below the x-axis? Inside the intercepts, right? So I can write that as a inequality, an and inequality. So it's between the -2 and the 4. If this inequality would have been switched, if it said where is this parabola greater than or equal to 0, then it would be outside. So then it'd be an or statement because it's over here and over here. I see some bewildered looks. What are your questions? All right, here's another one. All right, so I can factor a 2 out, right? And from this step to this step, all we did was put the parabola in front. We just rewrote it with the 0 in the back. So you can just put this in the front. It was the less than part. It's still the less than part. 0 in the back, just to make the work up front. So that would be 2x minus 3x minus 10, because I factored a 2 out front. When I factor that, I get +2 and -5. So where are my intercepts here? -2 and +5. Good. I did the multiply add. Multiplies to -10, adds to -3.
So why did you take 2 out first?
We always take a 2 out first. If there's a greatest common factor, you always do that first. Now, is this going to open up or down? Up. So you can just sketch it really quickly that it's opening up. If you want to be more precise, find the vertex, go through all that stuff. But remember, all we're concerned about on these is where it's above or below the x-axis. You can tell that just by a quick sketch. So we are looking for where is the graph below the x-axis. Remember, I am looking for where is this parabola less than 0. 0 is our x-axis. So where is it below the 0? It's either in between the intercepts or outside of the intercepts. What do you guys think? In between. So I would say in between using -2 less than x less than 5. Notice on the last one we use equal to because it was a solid parabola. Here we're just using less thans because it's a dashed or a dotted parabola. So just be aware of that. Now, This is kind of tricky. I understand that. So make sure you do your homework tonight. There is one other thing I want to show you guys. So if it says algebraically, we can do a bit of a simpler method actually than graphing on a coordinate plane. Some people don't like it because it takes a little bit more deeper thought. But when I factor this, I'll go through the factoring step pretty pretty quickly, I mean. So we have x plus 2 and x minus 5. So my intercepts here would be negative 2 and positive 5. We call these critical values. Critical values is kind of where a change happens. So this is where it's going to touch the x-axis. So it's either going to go from being positive to negative or negative to positive y values. So those are critical values. So on the number line, I would graph the negative 2 and the positive 5. Now, we are looking for where is this less than 0. So we can test a point over in this value and decide if it's less than 0. We can test a point in this value and decide if it's less than 0, and one over here and decide if it's less than 0. So you test one from each interval and decide if it's above the x-axis or below the x-axis, so if it's positive or negative. So I can test negative 3. So all I'm doing is plugging negative 3 in here. That would give me 9 plus 9 minus 10. That would be positive 8, right? So that would be a positive value. All we care about is whether it's positive or negative. If we graphed it, would it be above the x-axis or would it be below the x-axis? So if we're thinking of a parabola, if that range or that interval is above the x-axis and it's going to hit the x-axis at negative 2, what do you think it's going to be in here? This is above the x-axis. It crosses the x-axis, so now where would it be? It'd be negative. So you could test a value in here. We'll test 0 real quick. You could see you'd get negative 10. So that would be a negative value. And then again, over here, we'd be above the x-axis again. It'd be a positive value. So it's just kind of deciding, would your parabola be above the x-axis or below the x-axis? And then our question is asking us, where is it less, we're not done, where is it less than 0? Well, it's less than 0 in this interval right here where it's negative. So you would say negative 2, less than x, less than 5. Please try your homework tonight. It is listed on your green sheet. I understand this is kind of complicated. It's the first time you've seen anything like this. So come with questions tomorrow. We can do questions on the board. If you don't have any questions, I'll assume that you guys figured it out. You got it. So just let me know where you need help with tomorrow.